Good afternoon. My name is Petros Pizanis. I'm an electrical engineer currently working at Piraeus Container Terminal, well known as COSCO, at the engineering department and at the R&D department of COSCO. I would like to apologize first for my English because I haven't used them since I took my proficiency degree. So please be patient. And I'm going to use my notes, so please allow me to have this. The title of the presentation is called Experimental Investigation of Harmonic Distortions in Port Crane System. We are going to discuss harmonic irregularities of voltage and current in a system, which is to be described later, and how we can act to obtain maximum reduction. The results obtained through the testing procedures in order to achieve the correct working condition and most environmental friendly state of the machine in steady. Here are the strict standards of the IEEE, European Technical Commission, and Electrotechnical International Commission. Those were followed and updated by during the testing procedures. And further details you can find at the network. At this slide, you can see the quay crane, which is separated into 4 different sections. First one is gantry. Gantry drives the machines, left or right, to place it in the correct position for loading or unloading. This system consists of electromechanical equipment which is transferred through movement on rails, as you can see. Second one is hoist. Hoist is the motion which is responsible for the lifting and lower the container load with a special locking and unlocking mechanism called spreader. Third one is trolley. Trolley does the horizontal movement of the crane, which allows the operator to move from vessel to shore or in the reverse order. And last one is boom. This is a large metallic frame which is lifted once operation is complete in order to allow a vessel to depart or to arrive safely without risking the crane hitting the vessel. Once a vessel arrives at the port, the operator lowers the boom from its vertical position to its horizontal position, allowing the operator to work his trolley and hoist motions. All the movements of the crane are made through the use of electrical energy and are based on synchronized systems of electrical adaptation transferred with semiconductors. Here I would like to give you the minimum of understanding the machines. The working procedure of the quay crane, QC, is to transfer load, import or export, situated in a metallic container from a sea vessel to land through electromechanical devices installed on the crane. Likewise, the reverse action is done when loading a vessel to shore. The operator lowers vertical movement through a hoisting device into the container, then through a device named spreader, as we said before, locks into the top of the container, where he then passes a locking command through the cabin in order to the spreader to lock its mechanical twist locks into the container. He then lifts the load and transfers it through horizontal movement of the crane to reach the position where the container will be discharged. Operator then lowers the container, and when it reaches the ground level, it is then unlocked through the spreader, where an internal movement vehicle takes the container. The same process is made for each container either loaded or unloaded from the vessel. Now, these distortions of electrical power in this system cause harmonic fluctuations of voltage and current, known also as linear load. These deformations cause many problems of electromechanical system as well as to the environment. They cause stress on electrical circuits, electrical equipment such as relays and conductors, main power supplies, and even to transformers. They also cause electromagnetic interferences into electronic circuits and systems such as PLCs. Furthermore, harmonics cause economic problems, as a system which have harmonic fluctuations can also affect the power factor correction, where power supply companies can impose penalties for incorrect power usage to the company using the power. Those reasons lead us to investigate whether there is distortion are present in our working environment and also whether they can be rectified. For this to be achieved, we must study and record, so we could be prepared for the appropriate prevention system. The recording device which shall be used is the Flux 7035, which is a logger that records harmonics data with large accuracy and always in accordance with the IEC and European legislations. The record we got helped us to find and create an improved solution for to exclude these factors. The record meter allows to find volts and currents, their peaks and limits, and harmonic distortions from the first until the 50th harmonic. The logger is connected to the main supply of the QC, QI crane, after the transformer and on the low voltage coil in order to have a complete insight as to what was consumption being used on the QI crane and to be able to find the maximum distortion of the whole crane. The logger is connected as stated in its operating manual. In old crane technology, there was no harmonic filters installed. When the company I worked for first commenced operation at the port, they decided to install these filters so the crane will be more efficient towards the environment and also to reduce the electricity bills and penalties from the power supply company. As you can see in these pictures, with filters, the harmonic waveforms are very small compared to the next slide. Those are the harmonics, 3rd, 5th, 7th, 9th, and 11th. Compared to the next slide, which we have an old QC without filters. And we can see that the increasement is much bigger. Unfortunately, it's difficult to notice the difference here because you cannot interfere at the logger data. The scale is here, and it's 3 times more than the last one without filters. Now, from the other side, we can see a crane with a newer technology, which does have filters and also a system to regenerate return voltage during motor braking, thus making the crane more environmentally friendly and also acceptable. And as you can see, there are no harmonics, is almost to 0%. And the first one, of course, is not a harmonic. This is our fundamental frequency at 50 Hz. This project is not, I would like to tell you that this project is not yet finished. It takes lots of hours of measurements since our load is very unstable, because the different load of every container is about 1 until 80 tons. Also, this research is taking place to more than 60 machines. 60 machines with power supply from 1 kilovolt to 20 kilovolt. Yet the benefits until now are major, as you can see at the conclusion. We've got better quality power, better performance, lower breakdowns, and most important, there are no penalties from power supplier, and the terminal has been more environmentally friendly. As I told you, this is just only one crane. This research is going to be finished the next year at the end of 2016. And if anyone wants to have an expand from this research, you can communicate to this email.